Okay, grade 10, let's talk about writing and balancing chemical equations. Okay, this topic appears all over the place in the first two terms of chemistry, and it just is a problem to deal with because they expect you to know it earlier and they expect you to know it later, and it takes a lot of practice. So in all of chemical change, we have reactants going to products. Okay, this is one of the most important parts of chemistry, that if you have a chemical reaction, the reactants go to products, and the atoms on the left are equal to the atoms on the right. But the law of conservation of matter says to you that you can have a compound on the left and a different compound on the right, okay? A compound or a molecule or an ionic substance. So you have to be very clear in your mind what's the difference between an atom and what's the difference between a molecule or a compound, okay? So what we have to do here is when we balance an equation, if we're given the equation, we have to check the atoms on the left equal the atoms on the right. And if somebody gave you this reaction here, this is iron 3 oxide plus carbon goes to iron and carbon dioxide. This happens in a blast furnace when we produce pure iron. If you look at this reaction and you count the atoms on the left, they'll tell you there's 2 iron, 3 oxygens and 1 carbon, and on the other side there's 1 iron, 2 oxygens and 1 carbon. So you can see here there's a different number of iron atoms on the left than there are on the right. And the law of conservation of matter says the atoms on the left equal the atoms on the right. You cannot break this law. It is a law of chemistry, okay? So we have to learn to deal with it. So what we have to remember when we deal with this is what is the formula of a compound, and by the law of constant composition, one formula means one substance regardless of how you made it, okay? So water is always H2O. So the formula is the ratio of the atoms in the compound. Here in H2O, 2 hydrogens to 1 oxygen. So we write the number of atoms in each compound with a subscript, H2O. And this will always be water, no matter where you are in the world, no matter how you made it, this is water, H2O. 2 atoms hydrogen, 1 atom oxygen, okay? So this tells you what atoms in and what ratio they are in the compound. This coefficient tells you how many of something that you've got. So here's 1 H2O with an invisible 1. Here is 4 H2O. So this is a fundamental concept, and if you get this wrong later on, things get very interesting when you try to balance equations. So in 1 H2O, I've got 2 hydrogens and 1 oxygen, but in 4 H2O, I've got 4 times 2 hydrogens, which is 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and 4 times 1 oxygen, so 1, 2, 3, 4 oxygens, okay? So I've got 4 molecules of water, but inside my 4 molecules of water, I've got 8 hydrogen atoms and 4 oxygen atoms. So this is where you have to remember what this coefficient is doing. This coefficient outside is multiplying all the atoms inside. 1 H2O, 4 H2O. So this needs to be very clear in your mind before we go start balancing. Then this stock notation, this is to help you make chemical formulas, okay? So if somebody tells you, write me the formula for iron 2 oxide, this 2 in the brackets here is telling you that this is iron 2 oxide, Fe2 plus, and we know oxide is 2 minus, so we write the formula FeO, because the 2 plus on the iron balances the 2 plus on the oxygen, and this is now neutral. But if somebody says to me iron 3 oxide, which is rust, this is Fe3 plus, and the O2 is still the O is still 2 minus. So if I've got a 3 plus here and a 2 minus there, I balance them by moving the charge down to the other atom. So this is 2 minus, I bring the 2 down to the iron, and this is 3 plus, I bring the 3 down to there. And so then 2 ions will give me 6 positive charges, and 3 oxygens will give me 6 negative charges, so this is neutral, okay? So some Ions, like iron, can be 2 or 3. Same with copper. Copper can be 1 or 2. Lead can be lots of different things. So when they put this in the notation, you know what charge to put it with. So then you know what your cation charge is. And if you know your anions, then you know how many to balance with them. Okay, so that's what stock notation is. Now here's a new thing. We have to put state symbols. We know the states of matter, solid, liquid, and gas, okay? So we have to indicate the state symbols to indicate what's going on in a reaction. And often in grade 10, there's 4 marks for balancing an equation. 1 mark for the reactants, 1 mark for the products, 1 mark for balancing, and 1 mark for having all of the correct state symbols. So these are fairly obvious. Gas is G, liquid is L, solid is S, and anything we dissolve in water becomes an aqueous solution. Like for instance, if you see NaCl with an S, you know we've got solid salt crystals. But if you see NaCl AQ for aqueous, we know that we've got a salt solution. Okay, and so then their properties will be different. So here I've got a little picture of a precipitation reaction. Here's one colorless aqueous solution with another colorless aqueous solution, and when they mix together they form a precipitate, which is a solid suspended in the aqueous solution. So then if you look at a balanced reaction and you suddenly see solid in the products and there was aqueous reactants, you know that you formed a precipitate, and then you can answer the question on that. We're going to get more into reactions on aqueous solution next term, I think. So what else is written on with chemical reactions? The arrow is actually the most important thing on your chemical reaction. If you don't put an arrow in, they're going to mark you wrong. Okay, so if we write things on the reaction arrow, then you remember in grade 8 you often see the photosynthesis reaction, and then on the arrow they'll write chlorophyll, because you can't do photosynthesis without chlorophyll. It's needed for the reaction, but you actually don't it's not taking part in the reaction other than to speed the reaction along. So that's an example of something you might see written on an arrow. Here, if you see a triangle, this means heat. We also use the triangle delta. This is the Greek delta, capital delta. Delta normally means change, which is usually in physics final minus initial, but in chemistry sometimes we can mean heating. And later on when we look at reactions, they call it delta H, the heat of the reaction. The other thing that's much more commonly written on an arrow is a catalyst, okay? So a catalyst is something that speeds up a chemical reaction, but it isn't changed itself. It just goes into the reaction, and however much you put in at the beginning of the reaction will be there at the end of the reaction. It helps the reaction find an easier pathway. It's like cheating in an exam. So if you see a chemical formula on an arrow, that is the catalyst that helped speed up the reaction. So there are short rules for balancing equations, and there are long rules. Look here. Okay. In the short rules, you have to have the correct formula of the reactants and the products. Now this is usually given to you. If they say to you balance a reaction, they've usually written the correct formula. They don't always ask you to find the formula yourself, because that just can lead you down the primrose path into error. Okay. So the first thing you do is you find out how many atoms are on either side of the arrow, and you write them down. Make a little table or something of I've got this atoms and I've got this many on the left and this many on the right. Then you have a look which side has got more, which side has got less. So if you've got more reactants than products, then you need to add to the product side, okay, until the reactants and the products are equal. And you use the coefficients. You never ever change the formula of the reactants or products. You only add the numbers in front of the formula, the coefficients, okay. Remember, as you change the coefficients, like if I went from 1H2O to 2H2O, I went from having 2 hydrogens and 1 oxygen to having 4 hydrogens and 2 oxygens. Okay, so the moment you fiddle with a coefficient, make sure you fiddle with all the atoms in your little table underneath that that you are changing when you change the coefficient. And there, if you can put the state symbols in. Remember, there's actually not many things that are liquid at room temperature. So have a look here. If I gave you this reaction between copper and silver nitrate goes to copper nitrate and silver, if you start here, there's one copper atom on the left, and then there's one silver atom, one nitrogen atom, and 3 oxygen atoms. And on the right, one copper atom, but we had to balance copper nitrate. This is Cu2 plus, and nitrate is NO3 minus, so we have 2 nitrate ions per 1 copper ion. Okay, so we have the one copper atom, the one silver atom, but there are 2 nitrogen atoms because it's NO3 twice, and there are 6 oxygen atoms because it's O3 twice. Okay, so if you have a look here, copper 1, copper 1, copper 1, copper 1, so we're balanced. Okay, silver 1, nitrate 1, nitrate 2. So now here on the product side we've got 2 nitrates, but on the reactants we've only got 1. So we have to add a 2 over here. So if we put a 2 in front of the silver nitrate, okay, by changing this, if you have a look at this table, relates to this table, all of a sudden the silver goes to 2, which is what we wanted. I mean, no, it's not what we wanted. We wanted the nitrate to go to 2. The nitrate goes to 2, which was balancing the nitrates out, okay? But the problem came that now we've got 2 silvers, okay? So my silver went from 1 to 2 when I added the coefficient. So when I added this coefficient of 2, the silver increased, the nitrogen increased, the oxygen increased, and I ended up with 2, 2, 6, because 2 times 1 silver, 2 times 1 nitrogen, 2 times 3 oxygen. And now if I had a look, okay, I've got 1, 2, 2, 6, so my nitrogens and my oxygens are fine, but my silver was 1 initially on my product side. So now I have to change my product side over here so that I have 2 silver. So the moment I put this 2 over here, I had to say what else did this 2 affect, and I check in my atoms, and then I must fix now. I've got 2 silvers on the left, I must have 2 silver atoms on the right. Okay, so this is how you have to work. The moment you change one thing, you have to check for all the consequences of your action. Okay, so now remember, the only time you can play with a subscript is if they give you the name of the compound and you have to make a formula. If you're given the equation, you can't touch the subscripts. Okay, don't touch the subscripts unless they ask you for the formula of an individual compound. When balancing an equation, you may only use the coefficients.